So yeah, so the if you go to the link in the chat, you're basically going to end up here. This is kind of where we keep all the workshops so far, and also includes the YouTube video links for the first two workshops that we did. Now, today I got some stuff planned, but you know, within what group do we have is like we can divert and talk about anything you guys want to talk about. So typically what I do is like I pick a number of things to talk about, and then you know, of course, for the next ones, for the next workshops, you please let us know what would you like to see and what we should cover. But the first thing that I thought that we go over is this thing called types. There's a lot of kind of questions that both on Slack and our community forum and also internally people are asking and kind of getting confused about things like workflow types, signal names, query names, activity types, child workflow types, things like that. So I really wanted to kind of go over it. So both, you know, types are kind of represent the unique idea of your workflow and your activities, so of course, child workflows, and they're used for a lot of different things. Number one is, first of all, you know, when you're registering with a worker, a single worker can only register a single workflow type. Same thing like with activities as well. And also, you know, especially with registering your workflows and child workflows with the workers, you know, you have to kind of understand what signal and query names are, because they again have to be kind of unique within the same workflow type, and also with all the what do you say, workflows and child workflows, so you register with a worker. So what I wanted to go through is kind of like, typically I just show code, and for this we have a chapter 3 section 1, and what I wanted to show is kind of like talk about these types, all the different ways to manipulate the type name, and what kind of things we can run into when using types. So the first, this is just a demo code. And the first thing that I wanted to show is, okay, let's say that we have a simple workflow implementation. This is just a workflow that has interface called simple workflow, and it has a workflow method of exec. That's it. That there is nothing to this. But one thing that where we start encountering a workflow type is already when we start registering our workflow implementations with our workers. So in this case, we just register the same workflow type 2 times, and when we run this, we say simple workflow type is already registered with the worker. So what does that actually mean? When we in Java SDK define our workflows, they typically have to implement a workflow interface. And by default, with the Java SDK and Temporal, the name or your workflow type is going to be the type, the name of your workflow interface. In this case, what we did here, we registered 2 of the same workflow implementation, and both of them times we registered a simple workflow type with a worker, and we have seen that's kind of how it is. So one thing that you can do, however, is within your workflow method has a name parameter. And here, actually, you can define a different workflow type. So for example, ABC. So with the workflow method annotation and its name param, you can actually manipulate and set a custom workflow type that you want to set. But yeah, again, by default is the name of your interface. So the second thing I wanted to show is a type workflow implementation. And let's say this type workflow interface. So in this case, what we have is we have a workflow with some more stuff in it. So we do have a workflow method, execute, and we have a single method and 2 signal methods and 2 query methods. But one thing that's important to note is that these signal methods have the same method name. One is input signal that takes just in a single string, and the other one is the input signal that takes in 2 parameters. So let's say if we try to register this particular workflow with our worker and see what we get. So basically what we get is the duplication is not only on the workflow type level, but it's also on the signal level. And right now, the way kind of the Java SDK works is this duplication on registering, or this checks for signals, then queries, and then it's going to check your workflow type as well. So this is why we get this duplicate name of input signal. So let's go ahead and see how can we actually fix this. So by default in Java SDK, the signal name is the name of the signal method, right? So in the case where we have 2 and we get this particular error, you could control it via annotation. So for example, in this input signal method, what we're going to do is we're going to add a name param to our signal method annotation, and we're going to give it a specific name. So in this case, this one is going to be input signal, and this particular signal name is going to be input 2. So if we run this, our registration workflow again, now we get a new error. This says duplicate name of the query get input. So it's very similar also with queries. By default in Java SDK, the query name is the name of your query method. In this case, get input for both. But we can again control this similarly to, how do you say, the signal methods by adding a name param to your query method annotation and give it in a different name. All right, so let's now see that we have fixed signals and queries. In this case, what are we going to do now? All right, so with that, we actually fixed this particular workflow. So we have a single workflow type. And one thing to note, I already talked about defining a workflow type through the workflow method annotation, and we talked about signals and queries having to be unique. All right, so let's go ahead and stop this worker, and let's see what else we can do. The next thing that I wanted to talk about is activities. So let's go ahead, just like workflows have a type, activities have a type as well. And in this case, we don't register any workflows with our worker, but we're going to register 2 activities. And let's take a look at them first. The first one is going to be type 1 activity, and it has 2 activity methods. One is do something, and one is do something else. There is a small difference between workflow types and activity types in that, as we've seen with workflows, by default, the workflow type is the name of the workflow interface. With activities, each one of the activity methods define one of your many activities that you can define in this activity interface. So by default with Java SDK, the activity type is the name of the activity method with the first letter uppercase. So for this particular activity, it would be do something. And if we see out here also, this one would be do something else, again with the capital D, with the D capitalized. Now there is some other things that we can do with activity methods. So we can, just like what we can do with workflow types, we can actually set a specific name to the activity method. So for this case, we're saying this activity type for this particular activity method is ABC. In this case, it is ABC or lowercase. Temporal Java SDK does not, in this case, puts the A capitalized, but just to show that you can name that. And there is one more thing that I wanted to bring up, is the activity interface annotation itself has a name prefix. And this is a prefix that is applied to all the activity types that you define in this interface. So let's say, for example, we have this. So in this case, the activity type would be A underscore. So we applied the prefix, and then we use the ABC name because we have explicitly set the activity type, in this case, to ABC. And in this case, with the prefix, we would have A underscore. And then because we don't explicitly define here, this is commented out, this would be do something else. So this would be the activity type for this particular activity. So and this is very important, like especially like we said, not only with registering workflows and activities with your workers, but as you will see very soon, it's very important for, you know, when you create your different types of stubs as well. All right, so let's see. Oh yeah, okay, so we have also child workflow type. And just because child workflows are really, as far as when you define them, just like workflows, they do have a workflow interface. You can't control it the same way you control, how do you say, workflow types as well. So that's kind of like just some code that shows you, and hopefully, if any questions so far, please either add them in chat or just speak up, that will be fine as well. So we're starting off simple. The next thing that I really wanted to kind of go through is section 2, which is typed and untyped stubs. And there is always some sort of confusion in which one should I be using, which one shouldn't I be using, what scenarios should I use the type stub, what can I do with the untyped stubs, and stuff like that. So for that, let's take a look at, I'm gonna go ahead and see if anything is running. No, close all this up. And let's go to the second chapter. What we wanted to do here is start talking about all different stubs that are possible. So stubs basically are proxies. We can invoke our workflow and activity classes on their own. We have to do it all via the proxy. And the Java SDK, along with this proxy, really offloads all of your gRPC calls and everything that's happening behind the scenes. For example, when you say you want to start a workflow using, for example, a workflow stub, or you want to signal it or query it, there's a lot of stuff that goes behind the scenes that the SDK offloads from you, so you don't have to deal with it. But yeah, in the reality of things is we do have to use stubs in our client code in order to do pretty much anything with the defined workflows. So the first thing I wanted to talk about is a type stub. It is, you can receive it via client.new workflow stub. There is different types of methods or parameters that you can pass to this method. But basically, type means it is type safe. Instead of getting some generic stub class, as we'll see with untyped stub or stub, you actually get its type, so you get your workflow interface back. And you can use all the methods in a type-safe way from your workflow interface to start workflow execution, and signal query, and as we'll see, everything else. So with a type workflow stub, in order to, let's say, invoke this particular workflow sync, meaning we're going to just say workflow execute. Execute in this case is the name of our workflow method. So again, this is a type-safe way of doing this. And this is a blocking call, which means it's going to wait until execute our workflow actually completes and has a result. And then it's going to unblock this particular line of code, and we can get the result back. Of course, we can also, using type stubs, invoke workflow execution async. For that, we can use the API workflow client.start, and we give it a function. In this case, it's a workflow execute or workflow method, and you can pass it in some arguments. In this case, execute takes in a string. Using a type stub, we can signal by calling the signal methods directly. We can do the same thing with query by calling our query methods directly. And we can also, yeah, so let's see, get for results, but I don't know what I mean by this. All right. Now, one important thing about, how do you say, waiting for an async. So here we started a workflow using a type stub, and we created an async invocation, meaning that this line of code 42 is going to unblock as soon as Temporal has actually started workflow execution for you. It doesn't mean that your worker has yet picked it up or anything like that, but this is how, you know, we're as soon as the workflow execution starts, this line gets unblocked. So how can we actually use type stub to wait for the results of this execution? And we can't really do that. And this is kind of like one first thing that we're going to look into untyped stubs. So untyped stub actually is a proxy or a workflow stub that gets all the, instead of getting a type safe class or your workflow interface back, you get an interface called workflow stub. And it has a whole bunch of different methods like starting, signal with start, waiting for for your results, signaling, querying, and so forth. And we'll take a look at that. There is one really cool convenience method in the Java SDK where you can always convert a type stub to an untyped stub. So what that means is that here we can create an untyped stub, and we can just say workflow stub from type and give it our workflow stub, type stub that we have created. And at this point, we can use the untyped stub to say, okay, we have started our workflow execution async here. We're going to go ahead and say untyped.get result. And this is again a blocking, this is a call that can block. If our worker execution, which was started again async already completed, this is just going to return. If our workflow execution is still running, in this case, get result can be a blocking until the result is available or the workflow execution has completed. And in this case, we kind of have to know the return type of our workflow method. In this case, the execute method that we've called to start the work. All right, now a lot of times, like one thing that this untyped workflow method has is the signal with start, and this is a method which allows, it's a convenience method basically. Typically, when we want to signal to a workflow, a lot of times you have to check, say, okay, is this workflow actually running that I'm trying to signal to? And some people are trying to like use some list APIs or try to get, describe workflow execution to see the status. And then if it's running, then we're going to send it a signal. Well, signal and start kind of takes care of that, because what it does is basically you just call signal with start. And if the workflow execution is not running, it's going to start the workflow execution and then right away signal. Or if the workflow execution is running, it's just going to send the signal to the one that's already there. One thing that's kind of, usually people always use is untyped stubs for this signal with start. But I just wanted to show that in Java SDK, you can also have a type safe way of running signal with start. And for that, what we do is we say client.new signal with start request. And this is going to give us a batch request. A batch request for signal with start has to have two elements. The first one has to be a call to our workflow method, which in this case is execute. And the second call in this batch request has to be a signal method. So it has to have two. The first one has to be the workflow method. The second one has to be a signal method. And then we can send our signal with start command, passing in our batch request that we've created. So in case that you have a need to run signal with start with a type safe approach, so using a type stub, then you can use this highlighted code right now. Now, things like cancel and terminating a workflow and things like that right now, you have to use untyped stub. So you can just say, for example, untyped one.cancel or terminate and give it a reason and things like that. So if you want to send a cancellation request from your client, and you have a type stub, you convert it to untyped and then do that. All right, so the next thing I wanted to show is just, instead of converting a type stub to untyped, you can define an untyped stub right away. And for that, we say client.new untyped workflow stub. And there's, again, multiple methods that take different parameters. But here is where the workflow type, or this, when we talked about workflow type, really comes in. Whereas with type stubs, we use the workflow interface. Temporal SDK is able, through this interface, of course, derive the workflow type, because we said by default is the name of the workflow interface. When we're dealing with untyped stubs, of course, we can't derive anything, so we have to provide it as a string. So in this case, for our workflow C3 S2, we have this. We said this is the workflow type, so we can paste it here, and we can pass some workflow options there as well. Now, in order to start workflow executions, once we have an untyped stub, we can just say untyped.start. And this is very similar to when we did workflow client.start. And this is going to unblock when workflow execution is started. And similarly, what we've seen before, we can actually wait potentially for this execution to complete to get the results. With an untyped stub, we can send a signal. Now that goes back to the signal names and the query names that we talked about. This particular workflow has a signal method called add input. And by default, we said the signal name is the name of our signal method in Java. So this is the string that would provide. The same thing with query method. If we see here, our query method is get input, and that matches with the query type or the query name, which then will assure us that this particular query handler is going to handle the query request that we're sending here. If you want to send cancellations, we saw that, termination, and also signal with start using an untyped workflow stub works as well. To kind of continue with stubs, I'm just looking at the chat here. There's no questions. All right. So now that we have seen on your client side as far as starting workflow executions using the two different stubs. Now let's take a look now at so more stuff. There is more stubs. There is stubs everywhere with the Java SDK, and I think it's important to kind of go through this. Right now, what we're looking at is the actual implementation of our C3S2 workflow, chapter 3, section 2 in this case. And inside of our workflows, we a lot of times want to start execution of child workflows. Well, similar to workflow stubs, child workflow stubs have both typed approach, where you inside your workflow code called workflow.new child workflow stub, you can give it a child workflow or workflow interface to be invoked as a child workflow, and you give it child workflow options. So not workflow options, but in this case, you give it child workflow options that you have to define inside of your workflow code. Similarly, as with workflows, you call child.execChild. This is the workflow method of our workflow that we're calling here as a child, and we're passing in some input. Now, how do we actually invoke child workflows async using a typed child workflow stub? In this case, we use the async function. Now there is two. There is async function, and also there is async procedures. Typically, you want to use async function when your child workflows, in this case, or your activities, where you can use this as well, have a return type. So if for example, you have a child workflow that returns a result. In this case, you call async function. If your child workflow activity have a void return, so they don't return a value, you can use async procedure in the same way. And in this case, once we get a promise, async function returns us a promise, which means we can get the results later by calling a get method of this promise. So this is in line 22 is going to be a blocking call in this case that waits for this promise or execution in this case of our child workflow using the typed child workflow stub, and is going to block until we return a value or it fails. Of course, that is also an option. Similarly, with child workflows, you have untyped stubs. So you have child workflow.new untyped child workflow stub. Here again, you have to know the workflow type. So like we said, the child workflow is just a workflow. And by default, we use the name of its workflow interface. With untyped stub, we can start sync, I think, yes, with the execute method, and we can also start async as well. So we have two options, and then again, we can wait just like we did before. With untyped child workflow stubs, we can actually send signal to, let's say, we can send a signal to our child, and we can use child2.signal, and we have to know the signal name again. So this is where, again, it's important to know everything that we've talked about so far. But you can send signals inside your workflow, but you cannot query. So there is no child2.query. There is signal. And of course, you have execute async and blah blah blah, and you can look at all the different things that you can do with an untyped child workflow. All right, so the last thing I know I kind of beaten this to an end. I wanted to look at the actual child workflow implementation, and the reason for that is the last thing, activity stubs. A lot of times, either in this case, it's inside of a child workflow. For your case, it could be inside a workflow. You want to start, invoking activities, and there is more stubs. So for activity stubs, we call workflow new activity stub. We give it activity options, and it return is of course of type activity interface. The same thing with local activities, but the only difference is there is a difference between an activity stub and a local activity stub. It means you call workflow new activity stub, and here you call workflow new local activity stub, but also there is different options. Here it's activity options, and here you provide local activity options. So really, even though we get the same type of stub that is type safe, it doesn't matter how you want to invoke it depending on how you create. All right. So we can, of course, once we have a type stub, we can call all the different activity methods on it. So this is going to be synchronous invocation that waits for the do something activity to complete. You can also similarly use async function and async procedures, just like we showed to invoke child workflow sync or async. You can use that to invoke activities as well in async way. Just like everything else, of course, we have untyped activity stub, and you can create it as via workflow.new untyped activity stub. And you can call execute activity name sync. So in this case, let's see, I don't have this. Let's see which activity we want to call. Let's say that we want to call our do something activity. Wait, where was I? Child workflow. Here, sorry. And in this case, remember, we have to capitalize the D. So in order to invoke our activity with the activity type do something that would define an activity interface, we would have to use, in this case, the activity type or the name or whatever the parameter here is called. But we typically call it type and use a string there. And again, you can call async via execute async, for example, in this case. The last stub that I wanted to go over, there is one more, if you believe it or not. It's a new external workflow stub. So let's say instead of our child workflow, we wanted to signal our parent workflow, right? So there is some, or it doesn't have to be parent workflow. We want to, inside of our workflow, signal an already running execution that is external, meaning it's just running out there. So for that, what we can do is we can create a new external workflow stub. This is the typed way of doing it. And then we can call directly a signal method on ABC, or of course, you can get an untyped external workflow stub, and you can call the signal method. And again, in this case, you have to know the signal name, and you can pass it in some arguments as well. All right, so I think I've beaten these stubs to death. Any questions so far? Marco asks, no fully qualified Java name with package needed when specifying types. No, you don't need the packager. You just need the name of here. Yeah, package, I don't think it's taken in consideration. All right, so let's see. No more questions. Oh, so the name needs to be globally unique. Yes, or like we said, what you can do is define the workflow type here in your workflow method as well. Yeah. All right, so let's see. So we went through this. All right, so one next thing I kind of thought is when we talk about signals and queries, most of the samples and everything that, the way we think about how to set signals and queries is by, of course, what we've also seen so far is define your signal and query methods inside your workflow code. And let's go ahead and prepare for that. So when we look at, let's say, this particular workflow implementation, it has, well, let's look at the interface first. It has a signal method and it has a query method, right? So these are the two handler methods for the signals that come to our workflow execution with the signal name set input, like we talked about so far, and the query with the query name get input. But what if we wanted to add more signals and queries without actually changing the workflow interface? And a lot of times what this is useful is, let's say that we have a client that uses our workflow interface and uses the type stubs, let's say, a type safe way. They're only going to have access to set input signal method and get input. But what if we internally want to, for example, send an exit signal to this workflow, but we don't want our clients to actually know about it? And a lot of times, people say, well, I can't do it. But the reality is you can. You can define dynamic signal and query handlers inside of your workflow. And I just wanted to show that real quick, and then we'll run it finally, something again. All right, let's see where we are. So anyway, so this is our implementation of our workflow interface. So this is our workflow definition, basically. And we do override the signal and the query method, of course, we have to from our workflow interface. In addition to this, what we can do is we can register a dynamic signal handler. So this is a little bit of code that you have to write, but it's pretty cut and paste. So what we're doing here inside our workflow code, we're registering a dynamic signal handler. This signal handler takes in the signal name and the encoded arguments. So these are the inputs that we usually would pass to our signal method, like, what the data does the signal contain, or the payload. And then we can actually write our business logic here. So what we're saying is basically, if my signal name that I get through this dynamic signal handler is called set input 2, I'm just going to log a little bit for the sake of the demo, and I'm going to set our input 2 variable to the results. In this case, we get encoded arguments, and we define the actual type that those arguments need to be decoded to in order to set it to one of our local workflow variables. Similar with queries. Sorry, highlighted too many lines. We here register a dynamic query handler. It also takes the query type. So we talked about signal and query types many times so far, and also encoded arguments. And query methods can have inputs, just as a reminder. And also we say here in my query type is get input 2. I'm going to return my input 2. So how does this actually work? And the cool thing about Temporal is that it can handle both cases. Even though that we define the dynamic signal handler here, you would think that all signals would start going inside of our dynamic signal handler. But the Java SDK is kind of smart enough to know that if you have some, let's say, signal method defined explicitly here, like set input, this is going to handle all our set input, well, our signals with the name set input, this is going to handle it. And it's not going to send it to our dynamic handler. Same thing with queries. If you have some specific query methods defined, then, it's going to be handled like that. So this allows us to have some sort of, quote unquote, secret signal that we can send to our workflow, such as set input 2, that we do not expose to, let's say, our clients via type workflow stub in our workflow interface. All right, so enough talk. Let's go ahead and see what we're going to run. And what we're going to run is basically we're going to create a typed workflow stub for our workflow execution. We're going to start it async. We're going to call our set input method, which is the signal method that we explicitly provide through our workflow interface. And so, but note that we cannot set input 2. If you remember, our input 2 was actually, the dynamic handler, so we cannot, it's not exposed via our workflow interface. So in this case, we can convert our type stub to untyped stub with workflow from typed, like we talked about, a cool little convenience method. And we can actually send a signal with the name set input 2 and give it some arguments. And then we're going to wait for our results to workflow to complete. And then we're going to do the same thing with queries. We're going to first query our query methods, which is exposed via our workflow interface and the type stub. And then we're going to use untyped stub to query the same. Now, note here, just FYI, that it really shows that you can query workflow executions after they've completed. On line 48 here, we're waiting for our workflow execution to complete. And you can actually run queries even though that our workflow executions are closed. Now, remember just that's up to retention period, right? So if you have any questions on that. So whenever a workflow completes, we do have a retention period from 1 to 30 days. Once those 30 days hit, we actually remove the visibility in our workflow history. And if you want to retain it, you can look at the archival stuff on the docs and that feature as well. So yes, but anyway, so let's go ahead and run our workflow here. All right, so what we see here that when we have set the input 1 signal, we have handled it in our workflow implementation via our exposed signal handler, setting input 1 that comes from here. So Temporal SDK was still smart enough to say, okay, I have one explicitly defined. This is the handler I'm going to use. And when we send the second signal, we actually log this line of code, which then shows that because we didn't have an explicit signal handler defined, it used our dynamic handler. Same thing for, whoops, where did I go? Same thing for queries, both of our queries. This is the one that returned input 1 and was exposed via the interface, workflow interface, and this is the one that went inside of the dynamic query handler. All right. Good, any questions about this? I think that completes the signal section.
I have one question. Regarding signals, I'm not entirely sure if it's related. The question I have is, so I send a request to the outside, to an external service, and then now I am saying, hey, wait until I get a signal saying that process is successful via some webhook or something like that, some sort of thing that triggers a signal. And is there any way that I can say, hey, 15 minutes, probably retry the operation, like the previous operation of sending the message to the server again, like request to the server again?
For signals, so you're sending signals from a client or from inside of your workflow execution, or from from where?
Honestly, I just started working on like Temporal 2 days ago. So the idea is that we send a request to a like completely external service, and that service sends us a webhook back saying, hey, your processing is done. So I still need to figure out how from the, after receiving the webhook, I can send a signal to the workflow. I still need to figure that part out, but I'm just trying to understand if we can retry on not getting a signal for a while, like 15 minutes or something.
Okay, yeah, I mean, let's talk about this, maybe open a question on the forum, because there's a lot of things that go around that, and we can probably talk about this for a long time. There's some questions that I have.
I think that I maybe can answer this.
Go ahead.
So workflow code can wait on some value of the variable. For example, you can make a variable signal received or processing completed, and your workflow code can basically wait on a change of this value, and the wait itself can be timed. So what you can do, the workflow code can trigger a wait, timed wait, and wait for a signal to receive. And if timer expired, you can retry, for example, something that you trigger from the workflow.
Oh,
Probably
that makes
from
sense.
the workflow, you will trigger an activity.
Okay.
And if you're worried about potentially lost signals, this we try our best in general. In Temporal, like the whole system is built to basically never ever lose signals. So if you are able to communicate and send a signal to the Temporal server, after that signal will be delivered to your workflow. It
right.
never gets lost.
Good. Yeah, thank you, Dimi. Yeah, he's talking about workflow wait. You can wait for a signal, in this case, up to 10 seconds. So whichever happens first, either the 10 seconds or the unblock condition, which is your signal handler can actually set the unblock condition when you receive a signal. So in this case, line 44 would unblock after 10 seconds, let's say, if the signal.
Yeah, makes sense.
All right, cool.
Thanks a lot.
No problem. Thank you, Dimitri. You saved us as usual. All right. So anything else? Is there any sequence of signal delivery? What happens if two signals are received simultaneously? The order of signals is preserved in workflow history. So on, let's say, a workflow replay or something like that, the order is going to be in the same order that it was written into workflow history. If two happen at the same time, I think they will both be handled by the same workflow task when they're written into history. But Dimitri, do you know if there is a possibility that they, if they come in at the same time, it's pretty random, right?
I mean, they will be ordered somehow. They will be ordered deterministically somehow without guarantees. So your code should take into account that signals can be reordered. So if they come simultaneously, we will just do it somehow. Yeah, there is no alphabetical order and anything like that. It's pretty random.
Definitely. I think
something we said before in support is that we only guarantee sequential delivery of the same signal, same type of signal. So if there are different types, then they're not guaranteed to arrive in order. So there's different strategies to structure these signals depending on whether or not you really require the sequential delivery. Right, Tio? I don't know. Does that make sense?
I'm not really sure, to be honest with you, if you know it.
I put this somewhere in the docs. I'm not sure if it made it to the Java docs, but I put it somewhere in the signals concept stuff.
Yeah, but since we're talking about signals, I think I'm gonna just jump to section 5 real quick, because it has to do with signals, and this is a little fun demo that I hope it's gonna work. But basically, before I start talking about the section 5, I'm going to start talking about, well, a lot of people are aware is that even though with Temporal we say that a workflow execution can run forever and years and decades, whatever, it's true. But like every system, Temporal has its limitations, and the workflow execution is limited by this thing called workflow history size. And I don't know, we didn't go through this. We went through it through the first, in the first, how do you say, in the second, I think also workshops, but we looked before at the web UI, for example, and for each execution, as we talked about, has execution history. And in this execution history, you have a number of events. And there's a lot of really good videos and explanations and blah, blah, blah about what is the workflow history, what are these events, how they're used during workflow replay. I don't really want to go through it now, but if you have any questions, of course, we have Sean, Dimitri, and me will be happy to help with that, of course, now. But there is a limit on these numbers of events that can happen. I think, what is it, 50,000 events. And once a workflow history reaches this limit of 50,000, your workflow is going to get terminated by the server or the service. There is some warnings, blah, 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 that come every so, like I think 10K events, but they don't really help much. In a way, what I'm trying to say is that if you expose, like a workflow client can send 50,000 signals to your workflow execution, and that workflow execution is going to how do you say, get terminated. So you have to be careful, especially with signals and who you allow in a way to send signals to your workflows that you're running. But for this, and oftentimes the resolution, or always, is this thing called ContinueAsNew. And this ContinueAsNew feature, basically, we'll look at code and run it and everything now, basically allows you to, at some point during workflow execution, continue it as a new run. Now, ContinueAsNew has really two different applications. Number one, it can be really part or core of your business logic. We usually always think of ContinueAsNew in terms of this limitation of 50K history events, but it can actually be used as part of your control flow logic. You basically come to, let's say you get a result of your activity, you get a particular result per your business logic, and you can say, okay, at this point I want to continue either as the same workflow type, but ContinueAsNew also allows you to continue execution as a completely different workflow type without having to stop, and use client APIs or different. You just use ContinueAsNew. As soon as you call that, you will see in our demo your workflow execution completes with, I think, status continued, and a new workflow run is going to be created with the same workflow type. Now, so yeah, and then the second, of course, is the fact that we want to use it to control workflow history. And this is especially important when you're dealing with events. Like I said, events are recorded into history. Queries are not recorded into history, but they're still delivered via workflow tasks. But signals are kind of the thing. So the demo that I wanted to show for this is basically where we see 5. Okay, we jumped. Is we have a workflow here that has a signal method called add signal, and it has a signal method called exit. And what we're going to do in our starter is we're going to send, well, 50 signals to it, right? In reality, it could be 5,000 signals, so we can try that as well. But our workflow, what it's going to do is it's going to use this workflow await with a duration. So thank you, Dimitri, for bringing this up. So workflow basically says I'm going to wait for 2 seconds. And if I receive my exit signal, I am going to just return. But if I don't receive my exit signal within 2 seconds, I am going to call workflow continue as new. Now, there's 2 ways of calling continue as new, and thank goodness for all the stubs. There is also a continue as new stub, which we haven't talked about so far. You can call continue as new both type safe way and also untyped, like we talked about before. So you can create a new continuous new stub using a workflow interface, and you can call continuous new stub and call its workflow method. The way we're going to do it is basically just calling workflow continuous new. In this case, it is 100% guaranteed that this continuous new will, again, in the next run, be the same workflow type as where we're calling it from. So it's going to be C3S5 workflow. And we can also pass it in some information. So this count, so basically after each time that we waited here for 2 seconds, we've processed so many signals that were coming during these 2 seconds, and we call continue as new. We're going to pass the current count to the next execution, so we can start incrementing for each execution and see actually how many signals we have in the end handled. So the idea here is that we have a workflow that's constantly calling continue as new. So new every 2 seconds, this workflow execution is going to complete. A new one is going to be started via continuous new. At the same time, we're bombarding this workflow basically with signals. And the idea is, do we lose signals? Do we not? And just letting you know, my machine is very slow today, and we'll see what happens. But the idea is that basically we'll, number one, not lose any signals. But in addition, there is one more feature that hopefully during the demo, I can actually reproduce. So let's go ahead and run this and hope that it will work. So what we see here is this comes from the workflow. So this particular workflow has processed 4 events called continue as new, and we're keep processing events up to, I believe, 50. And we'll take a look at what happens. And I didn't get my error, so I wish I would get. Okay, here we go. There we go. This is actually what I wanted to get. And finally, we processed all 50 signals. So number one thing, we've sent 50. Let's take a look at our web UI real quick. So if we see all these continuous news, these are all our workflows. So this was the first one that received that we started. Its input was 0. And our second one is the continue a new execution, which receives 4. So the first workflow execution in the 2 seconds processed 4 signals and blah, blah, blah. Now, the one important thing here is this error that we received. And this is something that a lot of people think, oh my God, I've gotten an error in my code. But actually, it's something completely expected. And this is this invalid argument unhandled command. And I believe if we look at the history, this is, I think, the one before last. Let's see, maybe it's this one. Yes. See, and we also see it in the workflow history. Sometimes what happens is that as our workflow code is calling, sorry, I'm completely somewhere else. As we're calling continue as new, this is a gRPC call. It actually sends a call to the temporal service saying, hey, I'm done, start me a new execution of this workflow. While the workflow continue as new is running or being executed, one of our 50 signals came in. And temporal in this case does something very smart. It actually uses this unhandled command and it fails the workflow task to allow the last signal here to complete before we're calling continue as new. So this is really kind of like really cool on the server part, is that Temporal sees, or the SDK, Dimitri knows which one exactly, that continuous new is not done, but we've received a signal. It could be multiple signals as well, as we can run this and get this multiple times, and allowed us for this not to lose this signal, but to handle it before we actually continue to our last execution of our work. All right, any questions about that? No. All right, and thankfully we just got this, I think, 1 or 2 times, which is fair. But if we, let's say, remove the sleep here, and I don't know if this is going to run, but send 5,000 signals. Oh, okay, fine. I don't want to kill my machine completely. We should see these things happen a lot more. See, so as we're sending more signals in a very, very high interval in this case, which probably you shouldn't be prepared to get a lot of these things currently. And you see at the end, even when we had no sleep between our workflows, our sending a signal, and we send 1,000, we didn't lose a single signal while our workflow was going continuous new all along. Every 2 seconds, basically. Okay. Yeah. So now this is set for 2 hours, but we really only have a single section left, so which is fine. We don't have to always go for super, super long. So the last section is very, very short. I did not prepare more, but of course we can talk about anything that you guys want to talk about. But basically I wanted to talk about client errors and of course setting up SSL or mTLS in your applications, especially in your client applications that need to communicate to a temporal server. Yeah, that is mTLS enabled. Now for that, here is a link that's kind of important. What we're going to look at is the mTLS or SSL support in Java SDK from the client perspective. But of course, if you want to use that, you have to set up your server with that as well. If you look at here, there's a link to a repository called sample server. And in here under TLS, you can see actual examples, server examples, how to set up client side only, and also simple and full as well, where you have full TLS support between even the different temporal services as well. So yeah, so this is not what I'm going to talk about, today, but we're, stuff like that. So let's take a look at the code at C3S4. C3S4. All right. So the first thing that I wanted to talk about is your client code. A lot of times, you're actually going to write this code, and there's a lot of exceptions that can happen here as well. As we talked about temporal Java SDK and other SDKs too, it's not just Java in this case, really kind of hide from you the gRPC connections and all that stuff that's going on with that. But we can't assume their client code is always going to be perfect. And in this case, what I wanted to show is that what kind of exceptions you need to kind of be looking out for when you're writing your client stuff, like, for example, the code that starts your workflow execution, signals them, waits for the result, and all this code that we have seen so far. All right, so let's think. The first thing that you have to think about is this thing called workflow service exception. And what we're doing here is we have some options here that we're not going to look at so far, but we basically create a service. By default, if you don't specify workflow service tab options, Temporal SDK, Java SDK, and the others, all of them are the same, is going to assume 127.001.7233, right? Is the port, the default gRPC port for the front end service. So you don't have to specify it here. And if you're running locally, that, let's say on Docker Compose, that's going to be already preset for you. So what I'm trying here is I'm going to start a workflow by just some random workflow type. And let's see if I can simulate, hopefully, an error. All right, so the error that we got is basically says task queue is not set on request. So what we have here is we created a workflow stub for a workflow, but we did not set, when we started this workflow, what task queue we should run on. So you can think of these task queues as dynamically generated endpoints on your temporal server that have this particular, I don't know, URI, or just, of course, in Temporal it's a name, but you can think of it as a specific endpoint that gets generated and where workflow activities and all those tasks get placed on the queue. But in this case, as you can see, we were able to catch this error. So we didn't like let the client die, and we still printed the error out though, so just to show, and we were able to catch it with a workflow service exception. So this exception is going to, if you forgot some particular, how do you say, parameters like in task queue or things like that, it's kind of good to catch it and handle it if you need to handle it gracefully inside of your client code. Now let's go ahead and put, now we're past there. And the second thing I wanted to show is an invalid gRPC connection. Sometimes in your client, whether that be you or your end users, they can set up options, different options. So in this case, what I'm going to do is I'm going to set some invalid options. Basically, I'm going to set my target address instead of a real one. I'm just going to send it 127.02 port 900. That doesn't exist. And I'm going to pass these options to my how do you say, to my workflow service stubs. So when I do that, then let's go ahead and run this particular code. All right, so we got a deadline exceeded error. So this is something that happened because we tried to make a gRPC connection to an endpoint or a front-end gRPC endpoint that doesn't exist. But instead of just letting our client completely fail, we're still able to catch our exception. In this case, the exception that we caught was a status runtime exception. And this is the client IO gRPC. This is actually a gRPC exception. So when you're doing client code, it's very important, I think, a lot of times to catch the status runtime exception to get possible things like deadline exceeded errors that could happen in many different ways. So in your client code, catching status runtime exception is pretty good. And this particular exception has a status. So in this case, it's going to tell you also that we have a status code of deadline exceeded, which means there, after a timeout of about 5 seconds, trying to connect to this particular gRPC endpoint on a front end that doesn't exist in this case, our gRPC call failed, and we were able to maybe gracefully check, handle that. So let me go ahead and fix this up so we're not going to use the fake options anymore. The third thing that I wanted to show is, let's say that we send a signal to a workflow that is not running. And that can happen, as we've seen, is like, as a client like sends thousands of signals or hundreds or whatever. You might have multiple REST endpoints or what, you described earlier in the question, webhooks that send signals to workflows. But what if we send a signal to a workflow that does not exist? So in this case, we're going to create a untyped workflow stub for a workflow ID that doesn't exist. So in this case, this particular new untyped workflow stub definition is used for, let me make that up, for a known execution. So one thing about workflow stubs that you also have to look at all the different methods here. There are, depending on the workflow options. So in this case, we're going to create an untyped workflow stub. And instead of doing that to start new workflow execution, we provided a workflow ID and optional run ID and workflow type. And this is going to get us a stub or trying to connect to an existing workflow execution with this particular run ID. And remember, workflow ID, and remember in Temporal, you can only have one single execution running with a particular workflow ID as well. All right, so I don't know what I'm doing here. All right, here we go. So we're going to create an untyped workflow stub for a non-existing execution, giving a non-existing ID. We never started this, and we're going to try to signal it first. So let's go ahead and try to run that. Okay, in this case, we were still able to catch this exception using workflow not found exception. All right. So another thing that you can do in your client code is if you send signals to different workflows and want to handle it gracefully, sending a signal to a workflow that is currently or doesn't exist or whatever, or is not running, you can catch this workflow not found exception. And the last thing I wanted to do, and this is a little bit weird, is queries. And if I run this, so basically I'm trying to query a workflow that doesn't exist. And in this case, oh, we got a workflow execution already running. Okay, I didn't try to start it. Weird. Let me see what's going on here. Okay, I guess we didn't wait for it to complete and we killed the worker. That's fair. So let's go ahead and run this again. Oh, maybe I need to get rid of the start. Well, my bad. Let's run this again now. All right. So that's it. So in this case, we just focused on this code. I should have uncommented this line before, but basically we create an untyped workflow stub for a workflow that doesn't exist, is not running, or never was started in this case. And we try to query it. And in this case, we get illegal state exception. And we can handle that as well. So anyways, I know it's a lot of exceptions to worry about, to think about, but it is important that you kind of get a grip, if you need to handle things gracefully in your client code, that you handle some of these exceptions, and how to handle it. I hope this helps a little bit. The only other thing I wanted to show, the last thing, is setting up SSL or mTLS, of course. And I'm not going to run this. I thought about using my own certs and stuff, but there's just no need for that. And we also have in the samples, Java samples, GitHub repo. So Dimitri added basically the same thing. But the idea is, I just copied it over, is that in order to connect to SSL, we have to set workflow service stub options. And the workflow service type options, we set the SSL context, passing it in the client certificate and a client key. And those things, basically are real certificates, your client certificates and keys that you have to have on your client code, and have to set it up, of course, on the server side as well beforehand. So, where am I? Okay, here. So, and we can still set a target endpoint like we've shown before, where we set the target endpoint to gRPC front-end service endpoint that doesn't exist. So most of the times when you're connecting to anything else but your local host or running something locally, you probably want to do the set target and make sure that you set it to a valid front-end gRPC endpoint. A lot of people set this up with some load balancing in front of the front-end service, temporal front-end service, and that can be done as well. Just make sure that you have those configurations right. Now, I don't know what load balancers you might want to use or not, but make sure that if this is received by the load balancer, number one, that it can talk gRPC. Number two, that it actually sends the request to the actual front-end service or front-end services that it's load balancing in your case. Anyways, so that's for that. Yes, and once you have the workflow service stubs with the SSL context defined, you pass it in the correct certificates and key. you can start using, you can use this workflow service types options to create a client. And then this client you have to use in both your code that creates the worker, because the worker factory, of course, takes in the client as a parameter. So you need a client to create your workers. In this case, this configuration helps your workers be able to connect and talk to a long pole to the temporal front-end service gRPC pod. Yeah, you know what I'm talking about. Using this credentials, but also your client code that where they use to start workflows. Basically, when you create your workflow stubs, has to use it as well. How many workers shall we ideally start per workflow? The general recommendation is to set it to 1 and saturate it, and then go from there during your testing, depending on your loads. There is also, I think Sean did a great video with Samar recently about production worker setups, and they talked about that, and I can try to link it. And Dimitri also wrote a great worker tuning guide as well that is in our documentation. I'll try to find the links for it. Just going to stop sharing right now.